In this lesson, the focus of our application of differential equations will be on objects in motion, specifically on falling bodies. Perhaps one of the most popular laws we have learned in physics is Newton's laws of motion. We're going to take a look at how we can model differential equations to describe the motion of a falling body with constant mass, m, moving along a line under a force, F. What's up, guys? And welcome to differential equations. Before anything else, let's hear our gospel thought. Let us remember that we are in the holy presence of God. In the name of the Father, the Son, the Holy Spirit. Amen. Our reading is from Hebrews 13:8. It says, Jesus Christ is the same yesterday, today, and forever. It's easy to read this verse and think, so what? Who cares if Jesus is the same yesterday, today, and forever? So why should we even care that Jesus is the same? Well, folks, the fact that Jesus is the same is a big deal. It means that He doesn't hate you one day and love you the next. It means that He doesn't send lightning bolts down to zap you because He's having a bad day. It means He is consistent. His love for you is consistent. Now, many people in our lives are fickle. You may have friends who one day turn on you because you wore the wrong clothes or said the wrong thing. That's not at all how Jesus is. He loves you. That love is the same every day. Take some time today to think about how great it is that Jesus is the same. That His love and opinion of you doesn't change. As Lasalians, may we respond in prayer and say, I will continue, O my God, to do all my actions for the love of Thee. Saint John Baptist de La Salle, pray for us. Live Jesus in our hearts forever. In the name of the Father, the Son, the Holy Spirit. Amen. Alright, so let's proceed and discuss today's topic. Mechanics is the study of motion of objects and the effects of forces acting on those objects. This is quite important. Basically, mechanics explain how things are moving and falling. Now, and being able to predict by what distance, magnitude of force, and time taken an object gives us an advantage of maximizing these parameters to our, advantage. Now, mechanics is the foundation of several branches of physics and engineering. Newtonian or classical mechanics deals with the motion of ordinary objects. That is, objects that are large compared to an atom and slow compared with the speed of light. Now, to construct a mathematical model of the motion of a body moving in a force field, one often starts with Newton's second law of motion. Now, recall from elementary physics that Newton's first law of motion states that a body either will remain at rest or will continue to move with a constant velocity unless acted on by an external force. Naalala pa ba natin yung ating high school physics? If we denote that mathematically or describe it mathematically, the net force or the summation of forces along an axis is equal to 0. Okay, if a body is at rest or moving at a constant speed in a straight line, according to Newton, it will remain at rest or keep moving in a straight line unless it is acted upon by an external force. What else? Newton's second law of motion indicates that the net force acting upon a body is not actually equal to 0. No? When the net force is proportional to its acceleration a, or more precisely, F is equal to ma. where of course m is the mass and a is the acceleration. What else? When one body interacts with a second body, the force of the first body on the second is equal in magnitude but opposite in direction to the force of the second body on the first. As the popular Newton's law phrase says, for every action is an equal and opposite reaction. Now, experimental results for more than 2 centuries actually verify that these objects, or these laws rather, are extremely useful for studying the motion of ordinary objects in an inertial frame. What do we mean by an inertial frame? That is a reference frame in which an undisturbed body moves with a constant velocity. Now, it is Newton's second law, which applies to inertial reference frames, that enables us to formulate the equations of motion for that moving body. Now, we can express Newton's second law by a function f, no? Having parameters such as t, x, and v, no? Time, distance, and velocity, and that is the derivative dp, no, over dt, where f of t, x, and v is the resultant force on the body at time t, location x, velocity v, and p of t is the momentum of the body at time t. The momentum is the product of the mass of the body and its velocity. In other words, we have p of t equals p of t equals m multiplied by v of t, the velocity, right? Now, we can express Newton's second law using this idea as the function f of txv equals dp over dt, where again p is mvt, the derivative of that product mv, but we know that velocity, acceleration is dv over dt, right? So we have now typically so we have here m multiplied by dv over dt as one of our working equations. Now, typically, one substitutes the velocity equals dx over dt, right? The first derivative of distance x is actually the velocity. Now, for the velocity in this function, f of txv equals mdv over dt. And we will obtain a second order differential equation in the dependent variable x. In other words, a, acceleration, equals dv over dt, which is the second derivative of the dependent variable x. Now, however, in this lesson, we will be focusing on situations where the force F does not depend on x. This enables us to regard that function f of txv to be m dv over dt as a first order differential equation. In other words, we have f net equals ma from Newton's first law, and f net from Newton's second law, mdv over dt. Okay. I'm sorry, we have no, not Newton's first law, but Newton's second law only. That's f net equals ma, and we know that a is dv over dt. Okay. Now, before Galileo's famous experiment from the Leaning Tower of Pisa, it was generally believed that heavier objects in free fall, such as a cannonball, fell with a greater acceleration than lighter objects, such as a feather. Now, obviously, a cannonball and a feather, when dropped simultaneously from the same height, do fall at different rates. But it is not because a cannonball is heavier. Okay? The difference is actually due to air resistance. We will notice that the acceleration actually in these objects are the same, which is the gravitational acceleration of 9.81 meters per second squared. Now, under some circumstances, a falling body of mass m, such as a feather, with low density and irregular shape, encounters a resistance proportional to its instantaneous velocity. Now, if we take, in this circumstance, the positive direction to be oriented downward, then the net force acting on the mass is given by F to be the summation of forces, and that is F1 minus F2, which is the difference between the weight, which is mass times gravity, minus kV. No? We will notice here that we assign a reference frame, and we assign the positive velocity to be going downward, and in that reference, no, given that reference, yung ating mg yung magiging positive, and yung ating air resistance will be yung negative. Yung air resistance natin, obviously, since resistance siya, will be always opposite, no, the direction of the velocity, opposite the direction of the velocity. So, where we see here F1 mg is the weight, the force acting in the positive direction, and air resistance F2, also known or called as viscous damping, which is acting in the opposite or upward direction. Okay? Now, by equating the net force to this Newton's second law, we obtain a first order differential equation for the velocity v of t of the body at time t. In other words, mula doon sa ating Newton's second law, ma equals F net, no? And Newton's first law, which is the summation of all the forces acting on that body, which is F1 minus F2, in other words, mg minus kv, equating those two will give us a first order differential equation. This is now our working model or equation for us to be able to solve for the velocity given the velocity and time given the mass and the air resistance existing or present in that particular body. Now, a strategy we may employ in solving Newtonian models or falling bodies is first, no, to consider yung FBD or the free body diagram. Dito sa free body diagram, we quantify the forces that are present. No? Second, we choose the reference frame. In other words, what is the direction of velocity that we want to we want the direction to be positive, no? So by choosing that reference frame, we'll be able to have an equation, no? And we usually use or choose a reference frame that will be most advantageous to us. So, after that, we now apply yung ating differential equation kanina, which is differential equation model, which is m dv over dt equals yung ating net force, which is the summation of all the forces present either in the y-axis or in the x-axis. Okay? Also, I would like to remind everyone of the mechanical units in the English and SI system, no? Be reminded, kasi in the coming problems that we will be solving, it is important that we recognize the units that we will be using. That is why I want to refresh everyone's memory that for the English system, the mass is actually not in pounds, but in slug. Okay, in some books they call this as pound mass, no? Whereas force is pound force. But in some references naman, they simply drop the pound force and simply identify the force as pounds only. Yun. Kaya in English, the mass is usually termed as slug. Okay? And of course, for time seconds, for the acceleration due to gravity, we'll be using 32 feet per second squared. Doon naman sa SI, we'll be using 9.81 meters per second squared. Of course, the unit for force is Newton, time in seconds, mass in kilogram, and distance in meter. Alright, so to better appreciate our short refresher on Newton's laws of motion, we will proceed with solving sample problems. Okay. Alright. So, number 1. An object of mass m is given an initial downward velocity, so pababa daw, v0, and allowed to fall under the influence of gravity. Assuming the gravitational force is constant and the force due to air resistance is proportional to the velocity of the object, determine the equation of motion for this object. Okay. Quite interesting, no? Walang masyadong binigay na ibang details, but most details are abstract, no? Mass being m, velocity being v0. So let's define those, no, and quantify. Let's identify kung ano yung mga given natin. So sabi niya, the mass daw is m. So let m be that mass. Let v naught or v sub 0 be the initial downward velocity. Okay. What else? Of course, sabi niya rito, it is allowed to fall under the influence of gravity. So let that g be the acceleration due to gravity. What else? Sabi niya pa dito, assuming that the gravitational force is constant and the force due to air resistance is proportional. So let's call that FD, no? In other references, they call it FD as the drag force, the air resistance or the drag force. So ito daw yung force resistance. Or drag force. Okay. What else? And of course, yung x to be our distance. Yan. The distance the object has fallen or moved. Okay. Now, what is being asked of us to find, no? Required. We're being asked to determine the equation of motion for this object. So, ano ba yung ating equation of motion? Yung ating equation of motion is actually yung ating distance, no? But actually, that includes our velocity. But we'll only be able to get the equation of our distance once we're able to get the equation of our velocity. So, yeah, I think I'm taking in advance. But the equation of motion for this object that is being asked of us is actually yung ating distance equation. Okay? Kasi it describes kung nasaan na yung ating or yung distance or location ng ating object or body. Now, let's analyze the problem, no? Okay. So, una, let's draw a free body diagram of an object that is, sabi niya dito, falling downward, no? That has an initial downward velocity of v0. So, pababa siya and allowed to fall under the gravity or influence of the gravity. So, let's draw yung ating free body diagram muna. So, let's say this circle here is our object, no, or the body that is being considered. The forces that are active on this body actually are 2, just like what the figure on our previous slide. We have here yung ating force 1 and yung ating drag force, which is the resistance, the air resistance. No? And this F1 here is actually the weight, no, of the object, which is mass multiplied by the acceleration due to gravity. Whereas yung air resistance, that always resists yung ating, of course, kung ang ating air resistance, yung ating drag force or air resistance is going up because yung ating initial downward velocity is going downward, which is indicated naman dun sa problem. Sabi dito, initial downward velocity, right? So, ibig sabihin, yung direction ng ating velocity is going down. Now, kung yung direction ng velocity is going down, the air resistance must resist it, no? And it is going up. Usually, sa mechanics, diba, ang assumption natin is that walang air resistance. But in our case, dito sa differential equation, we will consider this air resistance. So let's call it kV. Saan nanggaling yung kV, no? Yung kV nanggaling doon sa relationship that sabi niya, the air resistance or the drag force is directly proportional to the velocity. Taas natin na unti. F is directly proportional, or the drag force FD is directly proportional to the velocity. At kung meron tayong direct proportional relationship, we can introduce what? Yes, you got it. A proportionality constant. Kaya tayo merong F equals kV. Okay? Now, initially, so ito yan. Initially, when t is equal to 0, no, nung hindi pa siya nababa, no, steady pa siya sa taas before it was allowed to free fall. When t is equal to 0, we can, of course, observe that the initial velocity, or the velocity, which is the initial velocity, is equal to 0 dahil hindi pa naman siya gumagalaw, right? And in this case, kung ito yung reference natin, the distance as well is equal to 0. So, kumbaga, kung let's say, nandito may isang tao sa taas ng cliff, no? Yan, na may hawak ng bola, nandito pa lang siya sa taas, no? Bago pa siya bumagsak, papunta rito sa ground. Initially, since hindi pa siya nare-release, of course, wala pang time dito, 0 pa siya. Wala pa ring velocity dahil hindi pa siya nare-release. And hindi pa siya nagmo-move, so yung distance nandito pa din. So kumbaga, we'll take that reference dito sa ating object, no? At kapag bumaba siya, syempre mag-i-increase din yung distance niya. So initially speaking, ito yung state ng object, all at 0. Okay? Yan. Okay, now let's further analyze the object, ano, and look at the what do you call this? The forces that are available. So ito yung FBD natin, ito yung designation natin for yung ating reference frame, and then susunod naman natin yung apply natin ng ating differential equation model. But first, paano tayo nag-arrive doon sa ating differential equation model? By analyzing the forces present here, by Newton's law, by Newton's first law of motion, Newton's law of motion, the first law, sabi natin the summation of the forces around an object is equal to 0. In other words, yung net force or F net is equal to ano yung mga forces na present dito. We have F1 and we have FD. So, since yung ating direction or reference is going down, So, ang positive natin is F1 and yung negative natin is F2. Parang Coulomb's, parang Kirchhoff's law lang din, current law. No? Papuntang node, yung coming, all the current, no, going towards the node is equal to the current going out the node. So, parang Kirchhoff's current law lang din. So, in here, ang positive direction natin, since yung F1 is going down, would be, well, F1. And yung negative would be yung ating drag force, which is FD. So, since F1 is mg, and yung drag force natin is kV, so that's mg minus kV. Okay. Now, by Newton's law of motion 2, the second law of motion, which states that the net force is equivalent to mass times the acceleration. This gives us F net equals m, for which the a, or the acceleration, is the derivative of the velocity with respect to time, dv over dt. Oops. Yan. Okay. So, equating the two equation, we'll have F net. So, this is equation 1. Equating the two, no? So, 1 and 2 will give us a differential equation. Yan. In this case, we have m dv over dt equals mg minus kv. Ayan. So, this is now our working equation, or the model that we'll be using to solve our DE. Okay? So, dun yan nanggaling. Now, what can we notice about our differential equation that has been formed here? You will notice that this is actually a linear differential equation. Let's divide m to the whole equation. Linear because, of course, take a look at the derivative, dv over dt. Yung order niya is 1, no? So, it is a linear differential equation. And yung ating mga coefficients are hindi, yung dv over dt, hindi naman wala namang nakatambal sa kanya na independent variable, so this is linear. So, what we're going to do is we divide m here to the whole equation, no? And we'll arrive at, since this is a linear differential equation, we'll arrive at a standard form. So, dividing m, we'll get dv over dt equals g. So, sige, lagay na lang muna natin para hindi nandito kung saan ang galing. mg minus kv. If you multiply 1 over m here, yan, we'll arrive at dv over dt equals m cancels out, no? So, tanggal si m. We'll get g minus k over m multiplied by v. Ayan. So, this v here, and this factor here, k over m times v, can be transposed to the other side. And we'll get dv over dt plus k over m multiplied by v equals g. Now, we can notice that this is the standard form of a linear differential equation. And from here, no, we can identify that, ito yung standard form. We can identify that p of t is actually k over m, and that q of t is actually g. The integrating factor is then mu of t equals e raised to the integral of p of t dt, which gives us, since p of t is k over m, both constants, we can factor them out here, k over m integral of dt, thus producing raised to e pala yan. Yan, okay. Thus producing e raised to k t over m. So ito yung ating integrating factor. Okay? Now, how about the general solution? Kung ito yung ating linear differential equation, no? The general solution would be, naalala pa ba? Since yung ating independent variable is v, that is v multiplied by, of course, mu of t equals the integral of mu of t q of t dt, and then of course, huwag kakalimutan yung plus c. So we have v multiplied by our mu of t, which is e raised to kt over m, equals the integral of e raised to kt over m multiplied by q of t, which is simply g, no, yung ating acceleration due to gravity, plus c. Since g, as we know it, is constant, then we can simply factor that out and integrate yung ating e raised to kt m, no, and dt, of course. Yan. So, alam na naman natin ang integral ng e raised to kt over m, and that is eu du. If our u is kt over m, then ang derivative niyan ay m over k, or eu e to the kt over m over its derivative, which is simply k over m. Right? Plus c. So this k over m here will become m over k, or simply m g over k, no? And then e raised to kt over m plus c, right? If we divide yung ating e raised to kt, if we divide e raised to kt over m to the whole equation, may eliminate to, and then magkakaroon tayo ng e raised to negative kt over m here. And so, we'll have an expression in terms of v as v equals mg over k plus c e raised to negative kt over m. Ayan. Now we have one part of our equation, which is the velocity. Okay? So what's next? After this, move lang natin dito sa side. After this, what are we going to get? We can actually apply yung ating initial value condition, IVP, for us to be able to know yung ating arbitrary constant C. So applying yung ating initial value condition, which is when t is equal to 0, when t is equal to 0, the velocity is equal to the initial velocity. So we can be able to find C. Okay? So, from our working equation, ito yon, from our working model, V equals mg over k plus c e raised to kt over m. We apply these conditions over here, and we'll be able to get, no, we'll be able to get V naught V naught equals mg over k plus c e raised to negative kt k0 over m. And as we know it, e raised to 0 is actually equal to 1. And so we'll have c equals v naught minus mg over k. Ayan. So substituting, we have now an equation which is v equals mg over k plus, yan, this equation here, v naught minus mg over k din, no? And of course, e raised to negative kt over m. Yan. So, mas buo na yung ating model. Of course, hindi muna natin in-assume na yung v naught is equal to 0 kasi if you want to derive a more general equation that would, an overarching equation that will consider v naught an initial equation, an initial velocity na maaring hindi pa, na maaring ma-define sa mga susunod pang problem. Kaya hindi muna natin siya in-assume as 0. No? So, in that note, ito yung ating differential complete, a particular solution for the differential equation, a more defined model. Okay? Now, hindi pa tayo tapos sapagkat yung velocity part pa lang yung ating nakukuha. Ang pinapahanap kasi sa atin ay yung equation of motion. Okay? Ibig sabihin, yung distance along the x-axis or the y-axis or kung nasaan man yung movement ng body. Now, since we know, humaalala natin that the velocity but v is actually equivalent to dx over dt. Change in distance or change in time. So therefore, we can equate this equation here. We have dx over dt, dx over dt equals mg over k. From this equation, since v is equal to dx over dt, and then we can substitute dx over dt in this whole equation here. And we'll get, of course, the same mg over k plus v naught minus mg over k e raised to negative kt over m. Yan. Now, we want to solve for x, yung ating equation of motion. So we need, this is a variable separable, differential equation. And so further, we'll get dx equals mg over k, multiply lang natin yung dt, plus, yan, plus v naught minus the same equation here, mg over k, then multiplied to negative kt over m, or raised to negative kt over m, and then dt. Yan. And so if we integrate this, if we integrate this whole equation here, we're gonna get a value for x. And that is x equals mg over k times t plus, yan, since this will be VO, V naught minus mg over k. These are all constants here, so pwede natin silang ilabas muna. And then we integrate this factor here, e raised to negative kt over m dt. Now, what is the derivative of this one? We'll have actually negative m over k e raised to negative kt over m. And of course, we must not forget yung ating plus c. So, move lang natin to dito muna. Oops, mabara. Since nag-integrate tayo, kailangan merong plus c. Yan. So, meron tayong mg over kt plus v naught minus mg over k, quantity negative m over k multiplied by e raised to negative kt over m, which is yung result ng ating evaluation of our integral here sa taas. Okay. Now, medyo incomplete pa yung ating DE because this is still a general solution. If you want to find a particular solution of the differential equation, you must therefore apply yung ating initial value condition again, which is yung ating IVP. Yung ating IVP, which is when t is equal to 0, x is equal to 0 kasi nag-start ka sa simula. And in that assumption, we'll be able to solve for the particular solution. So in that note, copying yung ating DE, we'll have when x is equal to 0, so ito yun. So ito yun, yung x na yun. mg over kt, so that will be mg over k multiplied by 0, plus we have v naught minus mg over k, and then move lang natin onte, multiplied by negative m over k e raised to negative k multiplied by 0 over m, and then of course yung ating plus c. Move na natin siya dito for more space. Okay, now since this one is equivalent to 0, and we know this one to be equal to 1, so magkakaroon tayo ngayon ng equivalent of VO C to be equivalent to, since this is negative, pwede natin siyang ilabas. Magkakaroon tayo ng V naught minus mg over k multiplied by m over k plus c. Right? Therefore, c is equal to v naught. Transpose lang natin itong buong to sa left-hand side. V naught minus mg over k. Di ko muna sila i-distribute para madali lang. M over k. Yan. This is now our c. Okay? And so, substituting yung ating expression for our particular solution, the particular solution, sige, saan ko ba ilalagay? Dito na lang sa kabila. Sige, copy ko muna ito, yung ating C, yung ating X rather. Yan. yung ating particular solution will now be okay. This is our value for x. No. Yan. So, for C, since ito yung value ng C natin, copy lang din natin. So, magkakaroon tayo ng equation such as okay, then copying this will have okay, this kind of expression. So further simplifying, this will give us x equals mg over k multiplied by t plus we can factor out actually mk, no, and have mg minus k. Ano pa bang pwede natin gawin dito? You can actually factor this out, yung ating mk v naught and multiply mg over k, no? So magkakaroon tayo ng ano pa bang pwede? Wait, sige. Ganito na lang gawin ko. Oops. So, labas ko na lang itong buong equation here. Kakaroon ako ng m over k. Labas ko muna. M over k and then v naught minus mg over k, no? And then, yan, meron akong 1 minus e raised to negative kt over m. Going to simplify this further to be x equals mg over k multiplied by t plus, factor out ko yung m over k or distribute m over k, initial velocity, minus m squared g all over k squared. Yan. Then of course, 1 minus e raised to negative kt over m. Ayan. So, x equals mg over k times t plus m over k v naught minus m squared g over k squared multiplied by 1 minus e raised to negative kt over m. Ayan. So now this is our particular solution. This is now our equation of motion. Ayan. Okay. So basically what we did here is we derived the equation given that we have generic given such as m being the mass, such as the initial velocity being v naught, and gravity and all the acting forces. So ang ginawa natin, pinakita natin yung derivation kung paano nakuha yung equation of motion. So in this model, no, given all the parameters of mass, like mass, gravitational, the acceleration due to gravity g, and then yung k natin, which is yung proportionality constant natin, dun sa relationship ng air resistance or drag force na directly proportional daw sa velocity, yung initial velocity. Having those, and of course time, having those parameters present, we will now be able to find the distance. So this is an equation of motion for this object. Okay. All right. So let's take a look at another solution, another problem. But before that, so the answer is yeah. Now, there is an important concept here that we must take notice. This is what we call the limiting velocity or the terminal velocity. Now, consider the figure, as shown on the screen. We have sketched here the graphs of the velocity and the velocity here and the position of the functions of t. Now, what happens when the velocity v of t approaches the horizontal asymptote, in this case, this horizontal asymptote here? Ano nangyayari, when this v of t approaches this asymptote? This v of t becomes equal to mg over k, as t approaches infinity. Okay, and that this position x of t, what happens here? It asymptotically approaches this line, yung ating nasolve kanina, which is mg over k t minus m squared g over k squared plus m over k v naught, So ano nangyari dun sa 1 minus e raised to negative kt over m? Well, ang nangyari sa kanya, naging 0 siya. Because when t approached 0, yung ating yung factor dito kanina na nasolve natin, di ba? Nakasama dun sa sinasolve natin is 1 minus e raised to negative kt over m, right? When it approached infinity here, yung ating e raised to negative k infinity here all over m will actually be equal to 0. Kaya kung mapapansin nyo, missing na siya dun sa ating equation. Wala na tong factor na to, yung 1 minus e raised to negative kt over m. Okay. Now, this, notice that the terminal velocity here, yung ating, sorry, let me put out the laser. Yan. Notice that the terminal velocity, which is this one, the limiting velocity, the value of the horizontal asymptote, yung ating horizontal asymptote here, the value of it for v of t in the graph below is what we call the limiting or the terminal velocity of the object, which is a solution of m dv over dt equals mg minus kv, yung ating sinulad doon. So this limiting or terminal velocity, we can call it v sub l, that is equal to mg over k. Notice that the terminal velocity here depends on the mass but not on the initial velocity of the object. Okay? The velocity of every free-falling object approaches this limiting value of mg over k. Now, while heavier objects do, in the presence of friction, fall faster than lighter ones, but for a given object, the terminal velocity is the same, whether it initially is tossed upward or downward or simply dropped from rest. Okay, so please do take note of this concept here of limiting velocity, na when t approaches infinity, as time goes by, it will reach a certain mg over k, a certain limiting velocity, kahit pa yan ay tossed upward or downward or just simply dropped from rest. Now that we have obtained the equation of motion for these falling objects with air resistance proportional to v, we can now answer a variety of questions. For instance, this question: a steel ball weighing 1 pound is dropped from a 2,500 feet distance with no velocity, 2,500 feet. As it falls, air resistance is equal to v over 8, in pounds, where V is the velocity of the ball in feet per second. We're asked to find the limiting velocity and the time it takes for the ball to hit the ground. Okay, so let's quantify the problem to understand it more clearly. Let's identify kung ano yung ating mga given. So given, I think we'll be able to more appreciate this if we draw it, no? So sabihin na natin na this person is dropping the ball from a certain height. Sorry, ito na lang. Okay. So, yan. Sabihin na natin. So, may person. Si Stickman. Okay. Dropping the ball. Okay. From this point hanggang sa baba. No? So, let's call this our ground. Okay. So, initially, nung yung bola ay nasa taas pa, the time, no, our reference for that is t is equal to 0. Okay, so since wala pa namang, hindi pa naman hinuhulog, no, initially, the time is equal to 0. At kapag yung time is equal to 0, the distance or the location is still equal to 0, no? So, hindi pa kasi siya nagda-drop down. If we assume that yung ating velocity is going downward, at yun yung ating reference, inertial reference, then pagdating dito sa baba, no, which is, hindi pa natin alam kung kailan mangyayari, but we know that the distance is 2,500 feet from the given problem, no? From the given 2,500 feet down na where it was dropped from. We can actually get this kind of idea, no, of the ball dropping down. Pero yun nga, question is, when will it happen, no, from the given, from the question. So, ano pa ba yung mga binigay sa atin dito? Sabi daw, may air resistance equal to V over 8. So, that's F. The drag force, or the air resistance, equal to V over 8. What else? Binigyan tayo dito ng 1 pound. Ano kaya yung 1 pound na yun? No? Yung 1 pound na yun actually is not the mass. Nasa English system tayo, remember? That 1 pound is the weight. The weight is 1 pound. Okay? Now that we have this information, no, we can proceed to required. Ano bang pinapahanap sa atin? We're actually being asked to find two things. Una, what is the limiting velocity, VL, no? And the time it takes to hit the ground, for the ball to hit the ground. And that is when x is equal to 2,500 feet. Yan. Okay? So let's analyze. So, tignan natin yung free body diagram ng ating steel ball, no? So, if this is our steel ball, we know that there are forces that are present on that ball, no? One of which is, of course, yung ating weight, which is our mg. And, of course, yung ating drag force or air resistance na binigay sa atin to be kV, pero since given is V over 8, no, we can identify here that k is equal to 1 over 8, correct? Because v cancels out and we have k equals 1 over 8. What else? So, from Newton's law of motion, no? Sabi ni Newton, for sa first law niya, by Newton's law of motion, the summation of all the forces is equal to 0. No? Therefore, F net, the net force, is equal to mg minus yun nga, kv. mg minus kv. So, itong k na ito, actually, kinuha lang natin mula dito para alam natin yung value natin ng k. So, obviously, yung k dito ay 1/8 times v. Okay. Wag malito, no? Kinuha ko lang mula dito sa taas itong value for our k. Okay. So, from Newton's law of motion 2, kagaya ng ating derivation kanina, no? Sabi niya, the net force is equal to mass times acceleration. Therefore, and since pala, yung ating acceleration is the derivative of the velocity with respect to time, and so equating the two, F nets, we have a model equation to be m dv over dt equals mg minus kv. Ayan. And so, since this is a linear differential equation, we can actually rearrange the equation and have it expressed as dv over dt plus k over m v equals g. So, ito na yung ating working differential equation. Okay? But k, as we know it, is equal to 1 over 8. And m is actually equal to what? Since yung ating given is from weight, and we know it as mg, no? You can actually compute for the mass as 1 or w over g, right? Since the weight is 1 and the what do you call this? The acceleration due to gravity is 32, no? So we have m is equal to 1 over 32. Yan. Ito yung m natin. So substituting, no? Meron tayo ngayong dv over dt. We have dv over dt equals or plus yung k natin, which is 1/8, and yung m natin, which is 1 over 32. Times v equals g. No? So this becomes 32 over 8 is actually equal to 4. So dv over dt plus 4 v equals g. Since this is a linear differential equation, we can solve for the standard form, or we can form the standard form as, since yung standard form pala ay dv over dt plus p of t times v equals q of t, we can identify p of t to be 4 and q of t to be simply g. Alright? The integrating factor, since nakuha na natin si p of t, is now equivalent to mu of t equals e raised to the integral of p of t dt, which is simply equal to e raised to 4t. Okay? So for the general solution of this dE is actually v multiplied by mu of t equals the integral of mu of t multiplied by the q of t and dt, of course, kakalimutan, plus c. So substituting, we have v multiplied by e raised to 4t equals integral of e raised to 4t multiplied by g, of course, dt, and then plus c. Yan. You can factor out g since it's a constant. It's 32 feet per second. And have 32 over 4 e raised to 4t. So in-evaluate natin yung e raised to 4t to be eu du. So that will become e to the 4t divided by 4. But since meron tayong 32 dito, feet per second from g, 32 divided by 4 times e to the 4t, of course, plus c. Yan. Now, expressing it in terms of v, and by dividing e raised to 4t to the whole equation, we're gonna get v equals 32 divided by 4 is 8. Tapos yung e raised to 4t cancels out kasi dinivide siya dito. We'll have c e raised to negative 4t. Okay. Now, this is our general solution for our velocity. Now, we can apply our initial value condition, which is when t is equal to 0, the velocity initially is also equal to 0, and we'll be able to solve for c para sa ating particular solution. So, we have when v is equal to 0, this will become 8 plus c e raised to negative 4 and then 0 kasi yung time natin is 0. Therefore, c is equal to, since e raised to 0 is 1, this will become 1. Okay. Thus, c is equal to negative 8. What is now, therefore, our particular solution? Our particular solution for our velocity, the particular solution for v is equal to 8 minus 8 c e raised to negative 4t. Yan. So this is now our particular solution for velocity. Okay? Now, ang hinahanap sa atin, solution, is actually the limiting velocity. So, pag limiting velocity, di ba, it is the velocity as t approaches infinity. So, limiting velocity is the velocity, is the v at t approaches infinity, right? Yan. So how do we solve for that? Well, from our given equation, we have v equals 8 minus, sorry, wala na palang c dito. Kung ba nilagyan pa ng c doon? 8 lang. E raised to negative 4t. Yan. So this will become 8 minus 8 e raised to negative 4 multiplied by infinity. So e raised to infinity is actually equal to 0. So the whole equation here, this whole term here, 8 e raised to negative 4 infinity will become 0. And thus, v is equal to simply 8. Yan, feet per second. Alright. So, yun yung long cut. Okay. But we know there's a shortcut for this, and that is by utilizing yung ating formula. So yun nga yung nangyayari, no? As it approaches infinity, yung exponential function mo here becomes 0. And when that exponential function becomes 0, you're left with simply yung 8 here, which is mg over k. So shortcut, we have VL, V, and then L equals mg over k, which is simply, ano yung mass natin kanina? 1 over 32 multiplied by our acceleration due to gravity, which is in English 32 feet per second, all over yung k natin, which is 1 over 8. Becomes, yan, 8 feet per second. Ayan. Yan. So this is our limiting velocity. Yung ating A. For B, we're asked to find when. Kailan ba magda-drop siya when x is equal to 2500. Okay? So when t, what is t when x is equal to 2500 feet? So since given tayo ng distance, we need to find out or figure out yung ating equation of motion, which is x. Wala dun sa ating given equation, which is this one. Ito nga. V minus 8 minus 8 e raised to negative 40. We have, since V equals dx over dt, no, then we have dx over dt equals 8 minus 8 e raised to negative 4d. Ayan. So integrating this function with respect to t, meron tayong dx equals 8 dt minus 8 e raised to negative 4t dt. Integrating this function here, this whole equation, kakaroon tayo ng x equals 8t minus 8 negative 1 over 4 e raised to negative 4t plus c. Ayan. Okay. Now, since meron pa tayong plus c, it's still a general solution. We need to implore yung ating initial value condition, which is when t is equal to 0, the distance x is equal to 0 initially, since ida-drop pa lang siya. So, in this case, magkakaroon tayo ng x is equal to 0 equals 8 multiplied by 0 then, plus, in this case, since 8 divided by 4 is 2, 2 e raised to negative 4 multiplied by 0 again, plus c. Okay? So we can solve for c here, and that is equal to, equivalent to negative 2, since 8 is 0 as well. And e raised to negative 0 is 1. Yan. So therefore, yung ating particular solution for x is 8t minus or plus 2 e raised to negative 4t minus 2. And from this equation, this particular equation or particular solution, we'll be able to solve for the time t given x is 2500. Yon. So at x is equal to 2500, what is the time? So x, when x is 2500, so this will become 2500 equals 8t plus 2 e raised to negative 4t minus 2 by shift solve, no? Or t. Labas natin yung calculator natin. Okay. Yan. Move ko lang ng kaunti. Okay lang. Yan. So, sa calculator natin, we have 2500. Oops, sorry. Sa calcu, we have 2500 equals 8t, 8. Let's substitute x for that t plus 2 e raised to negative 4 and then x ulit, then minus 2. Okay, and then by shift solve, we have 312.75. Okay, 312.75. 312.75 seconds, or divided by 60, no? We have 5.12 minutes. 5.21 minutes. So medyo matagal, no? 5 minuto. Haba naman kasi ng 2,500 feet. Yan. So it will take 312. It will take 312.75 seconds or 5 minutes before the steel ball reaches 2,500 feet. Okay. All right. So let's move on to another problem. Yeah. So we have number 3. A 960-pound object is given an initial upward velocity of 60 feet per second near the surface of the Earth. The atmosphere resists the velocity, or the motion rather, with a force of 3 pounds of speed for each feet per second of speed. Assuming that the only other force acting on the object is constant gravity, we're asked to find its A, velocity v, as a function of t, and b, its terminal velocity. Okay. So again, quantify natin yung problem by determining ano ba yung given. So, binigyan tayo ng 960 pounds. Ano yung 960 pounds? That is obviously the weight, right? So, the weight is 960 pounds. What else? Of course, yung ating acceleration due to gravity is 32 feet per second squared. What else? We can quantify yung mass natin, since mass is equal to the weight over the gravity. So that's 960 over 32. No? This will give us a mass of 960 divided by 32 That's 30. No? 30, anong unit ng mass ng English system? Slugs. Okay? Alright. What else? So, binigyan tayo ng ball daw that has an initial upward velocity of 60 feet per second. So, ano yun? That's the initial velocity. 60 feet per second. Tama? Yeah. So, when t is equal to 0, when t is equal to 0, so drawing natin siguro yung ball. No. Yan. So, when t is equal to 0, what? The initial velocity binigyan tayo is 60 feet per second. Okay. Now, ang sabi pa dito, the atmosphere resists the motion with a force of 3 pounds for each feet of the atmosphere resists the motion with a force of 3 pounds for each feet per second of speed. Okay. Now, since yung ating drag force, Fd, is directly proportional to the velocity, no? We will notice na from here, yung ating drag force, no, by unit analysis, ano ba tong 3 pound for each feet per second na to, no? Let's take a look, no, by unit analysis. Yung drag force natin is actually in the unit of pounds, right? And, well, this will actually give us muna Fd is equal to kV. If we're going to analyze yung unit nito, this will give us pound, no? And ano ba yung K? Hindi pa natin alam kasi constant of proportionality yan. But we know yung V is the velocity and that is feet per second. Correct? Feet per second. Yan. So what is K then? K is actually has a unit of pound per over feet per second. Yan. So makatuwid, ano yung ano na to? Ano tong 3 pound for each feet of second? Yung 3 pound for each feet per second is actually equal to yung ating K. Yon. K is therefore equal to 3. Alright? So, what else? So, yung 3 natin is yung ating constant of proportionality here. At paano natin siya nakuha? We simply looked at the unit, 3 pound for each feet of 3 pound for each feet per second of the speed. Okay? So, what else? Ano pa bang pwede natin ditong i-quantify? I think mukhang yan na yan. No? So, let's go to and proceed to required. So, ang pinapahanap sa atin, una ay yung velocity, yung equation of the velocity, V. What else? Pangalawang pinapahanap ay yung terminal velocity or the limiting velocity, VL. Okay? Yeah. So let's analyze the problem. Analysis. So, tignan natin yung free body diagram, yung object natin. So, we have that object assuming na circular siya. Hindi naman natin kino-consider pa yung shape niya for our analysis. So, we have here yung weight, of course, and which is mg. But let's take a look, no? Automatically ba na upward yung ating air resistance? No? Sabi kasi dito, a 960-pound object is given an initial upward velocity. So, yung initial velocity pala niya, hindi downward, kundi upward. Okay. At kapag upward yung velocity natin, how will we find, so pataas siya eh, syempre. How will we find the air resistance? The air resistance is actually opposite, no? So, pababa pala siya yung ating drag force, which is equivalent to kV. Nakuha natin na si K, which is 3. So, this will become 3V. Tama? Okay. So, from Newton's law of motion, no, we have mg, yung ating working equation, or mdv over dt equals mg negative mg minus 3v. Bakit negative? Kasi nga, yung ating reference for the velocity as indicated from the problem. Sabi doon sa first line, a 960-pound object is given an initial upward velocity. So if we'll take that as our reference, upward, yung ating forces, which is weight always going down because of the acceleration due to gravity, and yung air resistance natin, which is opposite of the velocity, di pareha silang negative. Negative mg minus 3v. Okay? So, this is a linear differential equation. And so, by rearranging yung ating dE, we're gonna get dv over dt equals negative k over m, or negative 3v, or simply negative g rather, negative g minus 3 over m v, right? Yeah. So rearranging this will give us dv over dt plus 3 over m v equals negative g. Alright. So, but we know m from our given equation here. We have m is 30. So therefore, 3 over 30 is actually 10, no? So we have dv over dt plus 1 over 10 v equals negative g. Okay, yeah. So from here, we can identify, or we can see this. We can already form. This is already a standard form, no, nung ating differential equation. And so from here, we can identify that p of t is 1 over 10, no, and q of t is negative g. And so getting our integrating factor will give us mu of t equals e raised to the integral of p of t dt, which is e raised to t over 10. Okay, t over 10. And so yung ating general solution for this is given to us by v multiplied by yung ating integrating factor, mu of t equals mu of t q of t dt, and then of course plus c. And so substituting yung ating values na na-acquire na natin, we have v multiplied by e raised to t over 10 equals integral of e raised to t over 10 q of t, which is negative g dt, and of course plus c. Yan. So e raised to t t over 10 will give us, I'm sorry, factoring out negative g, no? We have integrating e raised to t over 10 will give us 10 e raised to t over 10. And of course, plus c. So dividing this e raised to t over 10 here to the old equation, we'll get an expression for v as negative 10g plus c e raised to negative t over 10. Yan. Now, since yung ating equation is still a general solution, we can solve for the particular solution by applying yung ating initial value condition. Okay? So, applying yung ating IVP, and that is when t is equal to 0, no? Yung ating initial velocity, v, ay binigay sa atin, di ba? To be 60 feet per second. Yan. So we can solve for c. And that will be 60 from here, from this equation. V equals negative 10g plus c e raised to negative t over 10. So it will be 60 equals negative 10g, which is 32, no? Plus c e raised to negative 0 all over 10. This will give us c to be equal to, pwede natin gamitin yung ating calculator pag tayo ay tinatamad, no? We can compute for 60 equals negative 320 plus c, comma c, because we want to solve for c, and then shift solve. Our c is equal to 380. Okay. We have 380. Ayan. So therefore, ang ating general solution is v equals negative 320, buuin ko na, no? Since g is 332, 320 plus 380 e raised to negative t all over 1 or 10. Yan. So this is now the equation that is being asked of us. Yan. All right. What's next? Since we're being asked to find for the limiting velocity, that's b. This is actually the solution. Since we're being asked to solve for the limiting velocity, and we know simply VL to be equal to mg over k, and that is 30 times negative 32. Okay? Kasi yung tawag dito, yung reference natin is going upward, di ba? So yung ating gravity is negative 32. Over 3, we have VL equals negative 320 feet per second. Yeah, you can actually verify this, no? From the above equation, which is itong 320. Okay? Negative 320. Kasi ito, this equation here, as t approaches infinity here, this will become 0. And so we're left with negative 320. Ayun. Okay? So, kung yung reference natin ay upward, since indicated by the problem na upward, I'm sorry, nakaharap pala yung calcu. Since yung indicated velocity is going upward. Kaya yung ating acceleration due to gravity is negative 32. Thus, yung ating limiting is negative 320. This is also can be seen from our equation of V here, no? Na negative 320 na. Because at t approaches infinity, this will simply become 0. Left out. Yan. Yeah. So let's take a look at another problem. So we're asked to find an object of mass 3 kilograms. An object of mass 3 kilograms is released from rest 500 meters above the ground and allowed to fall under the influence of gravity. Assume that the gravitational force is constant with g as 9.81 meters per second squared and the force due to air resistance is proportional to the velocity of the object with proportionality constant k is equal to 3 Newton second per meter. We're asked to determine when the object will strike the ground. Okay. Sige. Again, let us quantify the problem by determining kung ano yung mga binigay sa atin. We have here, again, a person throwing or releasing rather a 3 kilogram object from an elevated distance of 500 meters. So kung meron tayong such person, no, in an elevated place again, just like this, let's say it's a cliff with the stickman, no, with an object, say an object like a circle, no. So yung mass daw of the object being released is 3 kilograms. What else? Yung ating acceleration due to gravity, of course, is 9.81 meters per second squared. And yung ating K, yung constant of proportionality natin for the air resistance, is 3. Yan. So, of course, initially, pag nandito yan sa taas, and if our reference is the velocity going down, okay, sabihin na natin this is our ground. And the ball drops here. So, syempre, initially, when t is equal to 0, the distance is equal to 0 then as well. Now, since yung elevation niya is 500 meters daw, so this is 500 meters. Hindi pa natin alam kung kailan siya tatama. Actually, yun yung pinapahanap. Diba? We're asked to determine what this t is. So, required what is t when x equals 500 meters. Yan. So let's analyze the problem. Analysis. Now again, the object or the ball has the following forces that are present to it. We have the weight, of course. Now, in this case, since it's falling down, we can set our reference for velocity to be going downward, no? Positive. Now, by air resistance, we have here the drag force or the air resistance to be kV, right? And so, we know this already, that the governing equation from Newton's law of motion, 1 and 2, will be m dv over dt equals the summation of forces to be mg minus kv. Yan. So from here, you simply apply. No? We know this already, that this is a linear differential equation. And it has a standard form of dv over dt, dividing m muna, equals g minus k over m times v. And so dv over dt plus k over m v equals g. Nakuha na natin si k, which is 3. Nakuha na natin si m, which is also 3. So therefore, 1 yung ating dv over dt. I'm sorry, yung ating k over m. 1 over 1 times v equals g. From here, we can identify already that p of t is equal to 1 and that q of t is equal to g. The integrating factor, simply by looking at it, mu of t is equal to e raised to the integral of p of t dt is actually equivalent to e raised to t, simply, right? Kasi p of t is 1. So, the general solution for this is v, diretso ka na, multiplied by e raised to t equals the integral of e raised to t and q of t, which is g, and of course dt plus c. Ayan. So integrating and or evaluating, kakaroon tayo ng g multiplied by e raised to t eu du, since 1 lang naman, no? Plus c. And so getting an expression for v, we'll have g plus c e raised to negative t. Now, since this is a general solution, we can employ yung ating initial value condition, and that is when t is equal to 0, the velocity initially is equal to 0 as well. Wala namang in-indicate na may initial velocity siya. So, initially, 0 siya. Hindi pa siya nire-release. Okay? So, with this condition, we can solve for c. No? That is, this is 0. We have g plus c e raised to negative and then 0. You know, this cancels out as 1. Therefore, c is equal to negative g, or negative 9.81. Right? So, thus, yung ating general solution, or particular solution rather, for our velocity will be 9.81 minus 9.81 e raised to negative t. Yan. This is our equation for velocity. Now, hindi pa tayo tapos dyan sapagkat kailangan pa nating hanapin yung equation for the distance, right? So, since v equals dx over dt, so we have dx over dt equals yung ating 9.81 minus 9.81 e raised to negative t. So, multiplying yung ating dt, we have dx equals 9.81 dt minus 9.81 e raised to negative t dt, and integrating both sides, we get x equals 9.81t minus negative t e raised to negative t becomes positive 9.81 e raised to negative t, and of course plus c. But since yung ating plus c, the general solution, we need the particular solution. So employing again yung ating initial value condition, and that is when t is equal to 0, hindi pa siya nakaka-alis, it is not being released, so wala pa ring distance covered yung object to be released. Right? So in that case, from our equation, we have x to be equal to 0 equals 9.81 times 0, because t is equal to 0, plus 9.81 e raised to negative 0 plus c. What do we get? This one becomes 1, right? And this one becomes 0. Therefore, c is equal to what? Negative 9.81. Pa rin. Hindi, yung isa kasi positive ata kanina. Tama? Parehas din pala. Negative 9.81. Okay, so substituting, therefore, meron tayong particular solution. The particular solution is x equals 9.81 t plus 9.81 e raised to negative t minus 9.81. Yan na yung ating working equation to solve the time given x is equal to 500 meters. So solution. When x is equal to 500 meters, what is t? Okay. So from 500 equals 9.81 t plus 9.81 e raised to negative t minus 9.81. By our favorite method, by shift solve, we'll get t equals 500 equals 500 equals 9.81, and then x plus 9.81 e raised to negative x minus 9.81. Shift solve. Yeah, 51.9683. 51.9684. Of course, in seconds. Yan. So, medyo mabilis lang, no? In less than a minute, magda-drop na yung 3 kilogram of mass from a half a kilometer above the ground distance of the object. Okay. Let's take a look at another problem. So number 5, we have a body of mass m, or of mass 5 slugs, is dropped from a height of 1,000 feet with zero velocity. Assuming no air resistance, we are asked to find una, yung expression for the velocity of the body at any time t, an expression for the position, and the time required to reach each ground. Okay? So, given, we have t. I'm sorry, no. Ganun ulit. Body is dropped, free fall. So, same scenario, no? Meron tayong person in an elevated condition or in an elevated height, a stickman drops an object, assuming circle siya, no? Just for the sake of illustration. Sabi dito, the mass is 5 slugs. So, the mass is 5 slugs. So, English system ang ginamit. And dropped from a height of 100 feet. So, dito yon, no? Sa baba. So, initially, of course, hindi pa siya ni-release. T is equal to 0 and x is equal to 0. Dito, hindi pa natin alam kung ano yung time. Actually, siya pinapahanap. Pero alam natin that the end is 100 feet. Right? So, what is being asked of us? We're being asked to find una, yung velocity. Pangalawa, yung ating distance. At pangatlo, yung time. Ayan. So, analyzing the problem, drawing our free body diagram of the object or of a particle, the forces that are present or active in the object are actually, well, yes, the same. The weight, the air resistance, no? Or the drag force. Since ganun pa rin siya, downward pa rin siya, yung ating velocity, our reference is downward. And so, by Newton's law of motion 1 and 2, no, we have m dv over dt equals mg, yung weight natin, mg minus kv. Yan. So from here, we have a linear differential equation. We have dv over dt plus k over m, v equals g. Shortcut ko na. Okay. From this linear differential equation, no, from this LDE, we have k. May value tayo for k. Meron ba tayong value for k? Wala. Kasi sabi niya, assuming there is no air resistance. So, when k is equal to 0, no, this one is equal to 0. So, this cancels out. So, wala tayong, well, linear pa rin naman siya, linear differential equation pa rin. Pero wala nga lang k over mv. What we have is dv over dt equal to g. Yan. And we know that this is a separable dE. Pwede mo pa rin naman yan i-linear, pero mas mahaba nga lang. dv will become g dt. And so integrating both sides gives us v equals 32, since tayo ay English system, 32t plus c. Okay? So ito na yung una nating sagot. Our first expression, v, is 32 plus c. Actually, hindi pa. Sorry. Kasi this is still a general solution. We still have to find for c, and that is by applying yung ating initial value condition. Okay. So, solution. Ito na lang natin siya ilagay. Applying yung ating initial value condition, which is t is equal to 0 when the velocity, which is the initial velocity, is equal to 0. So applying this, we'll have 0 equals 32t, which is 0, plus c. Therefore, c is equal to simply 0. So ang ating general or particular solution rather is v equals 32 only. 32t. Yan. (32t). So from here, we can proceed to getting our distance x. We have b, which is dx over dt. So from dx over dt, we have 32t mula dito sa equation natin, no? And so variable separable, integrating 32t dt, magkakaroon tayo ng x equals 32 over 2 is actually equal to 16 t squared plus c, right? Since this is a general solution, we need to apply again ang initial value condition natin, which is when t is equal to 0, the distance is 0. So therefore, 0 equals 16, 0 plus c, therefore c is also equal to 0. Thus, no? Yung ating equation, particular solution for the distance is 16t squared simply. Yan. Okay? What else? How about yung ating time? How do we solve for our time? Well, when x is equal to 100, binigyan tayo ng height, when will it reach the ground? What will this t be? Well, from the equation x equals 16t squared, meron tayong 100 equals 16t squared. So we have t squared equals 100 over 16. T is equal to 10 over 4, or equal to 5 over 2, or simply equal to 2.5 seconds. Yeah. So the answer is it will reach the bottom after 2.5 seconds. Medyo mabilis lang. 2.5 seconds. All right. Yeah. So number 6. Let's take a look at another problem here. Number 6. So we have a constant force of 492 newtons along a horizontal plane pulls a body weighing 1960 newtons, where the coefficient of friction between the body and the plane is 0.2. There is a wind resistance equal to twice the instantaneous velocity. We're asked to determine the velocity after 20 seconds. Okay. So this is a different kind of problem in the sense that hindi na siya simply just free fall, pero meron na tayo ngayong object that is being pulled along the horizontal. So quantifying the problem, we have a present force of 1960 newtons, which is the weight of the block. Now ano pang sabi? A constant force of 492 newtons along the horizontal plane pulls a body. So ito yung 492, it is being pulled to the right, where the block having a weight of 1960 newtons, where the coefficient of friction between the body and the plane is 0.20. So let mu be the coefficient of the friction, or the frictional coefficient, 0.20, Now, ano pang sabi? There is a wind resistance equal to twice the instantaneous velocity. So, meron tayong drag force or air resistance here, which is 2v. Okay? Twice the velocity daw. What else? We're asked to determine the velocity after 20 seconds. But ano yung mga hindi nabanggit doon na forces that are present dun sa object natin? Well, we have the normal force, which is opposite the weight, and we are able to get the frictional force, which is mu times Fn, by first getting the normal force. Okay. The normal force is the force that the surface exert to prevent solid objects from passing through each other, So the normal force is a contact force. If two surfaces are not in contact, they can't exert a normal force with each other. In this case, the object is exerting a normal force with respect to the surface. So, by Newton's law of motion, we know that the summation of all the forces along the y-axis is equivalent to 0. So therefore, 0 equals weight here minus the normal force will give us the normal force to be 1960 newtons. The frictional force here is mu times the normal force, and we'll have 0.20 times 1960. And so we'll have, from our calculator, 1960 times 0.20, 392. 392 newtons. Okay? Now, after natin sa y-axis, mag-summation naman tayo ng forces along the x-axis, which is equivalent to 0. And we know from along the x-axis where naandoon yung ating drag force, the net force that is present here, which is the summation of all the forces nga, is actually equivalent to, well, yes, this force here, let's call it P, the pulling force, P. If our reference is positive to the right direction, therefore P minus yung ating drag force, FD. What else? Meron pa tayo dito yung ating frictional force. So tatlo to na nasa x-axis, 1, 2, 3. Meron pa tayo na frictional force which is opposite dun sa ating positive reference. So this will be minus FF. Yan. So this will give us, since yung ating net force is also equivalent to dv over dt, m dv over dt, kakaroon tayo ng differential equation. We have P is 492 minus FD, which is 2V, minus our frictional force, which is 392. Yan. So from here, magkakaroon tayo ng mdv over dt equals 100 minus 2v, right? And then we have here what? What is our mass? Oh, wait, ilagay muna natin to dito. We have dv over dt equals 100 minus 2v all over m. Yan. But what is our m? No? What is our m? Given ba yung ating mass? Binigyan tayo ng weight here, no? 1960. Pwede nating makuha yung m, no? From the weight being 1960, we can get m, and that is the weight over the acceleration due to gravity. We have 1960 divided by 9.81. Okay. So, computin natin yon. 1960 divided by 9.81. So, we have 199.7961. Approximate na lang natin siya. 199.7961. 199.7961 or approximately m, para lang maging simple, equals to 200 since malapit na rin naman. So therefore, we have dv over dt equals 100 minus 2v all over 200, which will become now as simplified divided by 2, magkakaroon tayo ng 50 minus v all over 100. Ayan. Okay. So this one can be solved by variable separable. So meron tayong dv all over 50 minus v equals dt over 100. Yan. Okay. Okay. So integrating both sides, kakaroon tayo ng if u is equal to 50 minus v, we have du to be negative dv. So magkakaroon tayo ng integral of du over u, right? Negative du over u equals 1 over 100 integral of dt. Oops. Yan. Okay. So, if I move this negative here papunta rito, magkakaroon ako ng negative 1 over 100. Magkakaroon ako dito ng ln 50, or d over u is ln u equals negative t over 100 plus c. Okay. But u is 50 minus v, so therefore ln 50 minus v equals negative t over 100 plus c. If you raise this to e, may eliminate natin sa ln, magkakaroon tayo ng equivalent of 50 minus v equals C, e raised to negative t over 100. Right? Sige, quantify natin para hindi kayo malito. Alam natin na ito ay magiging e raised to negative t over 100 plus c. But we know na by properties of logarithms, this will be e raised to negative t over 100 times e raised to c, right? And we know that e raised to c is also equal to c kasi constant din naman siya. E raised to any constant will still be a constant. So therefore, this will become 50 minus v equals equals to c e raised to negative t over 100. So doon siya galing. Okay? Now solving for v, we have v equals 50 minus c e raised to negative t over 100. We have a general solution here. So applying yung ating initial value condition, and that is when t is equal to 0, the velocity is equal to 0. Hindi pa naman siya gumagalaw. And so, we have 0 equals, or dito na natin lagay, 0 equals 50 minus c, which is yung gusto nating solve, e raised to negative 0. So this becomes 1. Therefore, we have c equals 50. Right? So, ang particular solution natin is v equals 50 minus 50 e raised to negative t over 100. Now, ang tanong sa atin is what is the velocity? Solution. What is the velocity when t is equal to 20 seconds? What will be the velocity of the object? So, since v since v is equal to 50 minus 50 e raised to negative 20 over 100, this gives us v to be, mas natin calculate natin, we have 50 minus 50 e raised to negative 20 over 100. This gives us v is equal to 9.0634 or 35 meters per second kasi siya ay SI, meters per second. Ayan. Yan. Alright. Okay. So that is our answer. V is equal to 9.0635 meters per second. Di ba ang saya? Okay. For our last problem, yan. For our last problem, we have a familiar one. Yan. Number 7, Sonia Jean is 45 kilograms who drops from a helicopter 4 kilometers above the ground. Assume that the air resistance is proportional to the velocity of Sonia Jean with K1 is equal to 15 Newton second per meter when the chute is closed and with constant K2 is equal to 105 Newton second meter when the chute is open. If the chute does not open until 1 minute after SYJ paraglides, when will she hit the ground? When will she hit the ground? Okay. So for this problem, medyo dalawa yung ating scenario here because yung una, when the parachute is closed, nag-drop siya from above a helicopter of 4 kilometers above the ground. Meron tayo ditong K1, which is yung constant of proportionality natin for the drag force to be 15. So, pag close yun. Now, pag pinul niya na yung parachute, mag-open yun. Yung, of course, mag-i-increase yung air resistance. Magkakaroon ka ng 105 Newton second per meter pag open na yung parachute. Now, tinatanong sa atin is, after 1 minute, if the chute does not open until 1 minute, when will she hit the ground? So, kailan siya, magla-land doon sa ground. Okay? Okay. Yun. So, let's try and solve this, by quantifying first the problem. So, meron tayong 2 scenarios, okay? One scenario is when the chute is closed and the other is when the chute is open. So let's try and quantify the given problem. So, anong sabi rito? Yung diver daw or yung parachuter, si SYJ has a mass of 45 kilograms. So mass niya is 45 kilograms. Ano pang sabi? So, since nung tumalon siya, initially, t is equal to 0, and when t is equal to 0, yung ating distance is equal to 0 as well. And yung velocity niya, which is the initial velocity, is also 0. So, yun yung ating reference point. At this point, yung coefficient of air resistance is equal to, sabi niya rito, 15 Newton second per meter. 15 Newton second per meter. What else? Nung pagdating niya naman dito, sa pagbukas niya nung kanyang, tawag nito, when the chute is open, ito kanyang parachute. What happened here? This happened daw after 1 minute. If the chute does not open until 1 minute, so when t is equal to 1 minute, okay, which is i-unify natin since yung ating SI dito ay in seconds, in meters, so kailangan natin SI unit sila. So since 1 minute to this will be 60 seconds. Okay, what else? The distance x here is we still don't know, as well as kung ano yung velocity niya. Hindi pa natin alam. Pero dito, sabi, yung coefficient of, or constant of proportionality, K2 for the air resistance is 105. 105 Newton second per meter. Tama. Tapos dito, pag drop niya sa ground, dito sa ground na to, hindi natin pa alam kung kailan siya. Actually, yun yung tinatanong. When will she hit the ground? Pero alam natin na yung ground ay 4 kilometers or standardize natin 4,000 meters. Okay. Ginawa natin meters kasi itong K1 is in meters, Pag kinonvert pa natin yung 2 kilometers, magdi-divide pa tayo ng 1,000. So let's just leave it as it is at dito na lang tayo mag-adjust sa given natin. So 4 meters or 4,000 meters here. Okay. Now, ang tinatanong sa atin, so this is the given, okay. Ang tinatanong sa atin is simply when will she hit the ground if it is 4 kilometers or 4,000 meters high above the ground. So let's analyze the problem, Analysis. So again, as I've said, meron tayong two scenarios. Yung first scenario natin is when the chute is closed. And when that chute is closed, yung K1 natin, excuse me, is 15. Okay? 15. So, kunin natin yung free body diagram, no, nung ating diver, si Sonia Jean. Patawarin niyo ako, pero assuming that this is SYJ, tapos ito, nasa loob siya ng isang capsule. Oops, sorry. Yan. Okay. Sorry sa drawing. So, of course, when she was falling, the forces active on her are yung weight niya and what else? Yung air resistance, in this case, K1V. Right? Of course, ang ating reference is going down para same direction with the gravity, which is, of course, mg. Okay? So, by Newton's law of motion, move na lang natin siya dito. By Newton's law of motion, wait lang. By Newton's law of motion, one and two, our differential equation model is actually m dv over dt equals mg minus k1v. Correct? So, forming our differential equation model, we have dv over dt equals g minus k sub 1 over m times v. And so the dE is dv over dt plus k sub 1 over m v equals g. From here, we can already identify yung ating p of t, right? Since this is a linear dE. And that is k1 over m, which is, what is our k1? Our k1 is 105. Or no, our k1 is 15. Yes, 15. And yung mass ni Sonia Jean is 45 kilograms. So therefore, P of T is 15 over 45. 1/3. 1/3. And of course, Q of T is G, or 9.81. For now, gawin muna natin siyang G. The integrating factor, so nandun na tayo sa stage kung saan kinukuha na natin yung solution ng ating equation. The integrating factor mu of t is equal to e the integral of p of t dt. Tama? So we have e raised to t over 3. Okay. Now the general solution is v times mu of t equals the integral of mu of t q of t dt plus c. V multiplied by ano yung mu of t natin, which is e raised to t over 3, right? Equals e raised to t over 3 multiplied by q of t, which is g, dt plus c. Of course, integral. So magkakaroon tayo ng V equals, actually evaluating this integral first muna, meron tayong 3g, no? E raised to t over 3 plus c. Okay. Now, getting an expression in terms of the velocity v, magkakaroon tayo ng e raised to t over 3 cancels out here kasi if we divide this to the whole equation, magkakaroon tayo ng 3g plus c e raised to negative t over 3. So this is our general solution. Okay. So for a general solution, we need to apply an initial value condition, no, sa ating IVP. We need to apply the initial value condition, and that is when t is equal to 0, the velocity initially is equal to 0 as well. Kasi the chute is still closed. No? Paano pa lang siya? Pa-dive pa lang siya. So with that, meron tayong masosolve natin yung ating arbitrary constant, C. So we have 0 equals 3g plus c e raised to 0. Do you know e raised to 0 is 1? Therefore, c equals negative 3g. The particular solution, therefore, is v equals 3g plus or minus 3g e raised to negative t over 3. Yan. Okay. Now, what's next? We can actually solve for x. Why are we solving for v and why are we solving for x? Kasi kung babalikan natin, natitingnan natin, no, analyze natin yung problem. For us to be able to arrive here sa ating time, no, we need to compute muna kung ano yung ating distance and velocity bago siya mag-open ng chute. Kasi after that, we can only solve for this equation or this part, the last part, no, the time when she will hit the ground. After we have identified kung ano yung ating distance at kung ano yung ating velocity. Pag na-identify na natin to, this will be now our new reference. Okay? Our new reference for us to be able to compute kung ano yung ating time pag nag-land siya. Okay? So, kunin muna natin yung distance at kunin muna natin yung velocity. Nakuha na natin yung velocity, kunin natin yung distance next. Okay? So, velocity, ito na siya, yung particular solution. No? To get the x distance, let's call it v1, ano? And let's call it x1. No? For x1, we have v equals dx over dt. Yan. dx sub 1 over dt, which is equivalent to yung na-compute na nga natin, 3g minus 3g e raised to negative t over 3. Alright. So we have dx sub 1 multiplying dt to the whole equation. Magkakaroon tayo ng 3g dt minus 3g e raised to negative t over 3 dt. Integrating both sides, we'll be able to solve for x. And that is x sub 1 to be 3gt minus 3g and then negative 3 e raised to negative t over 3 plus c. Huwag kakalimutan. Yan. So this becomes positive 9. X sub 1 equals 3gt plus 9g e raised to negative t over 3, of course, plus c. So we need to apply yung ating initial value condition para makakuha tayo ng particular solution for this before we can proceed to the next level. So initial value condition is when t is equal to 0, the distance is also equal to 0, and we'll be able to find for the arbitrary constant c. So when in here x sub 1, no? Kasi ito yon. Initially, hindi pa naman siya maalis. We're still computing for the initial values. Ito yon. Let's call this x sub 1. Let's call this v sub 1. No? Yan. So let's call this x sub 2, v sub 2. No? Yan. Yan. So, applying yung ating initial value condition for x sub 1, we'll have x sub 1 to be 0 equals 3gt, 3g times 0 plus 9g e raised to negative 0 plus c. C will be equal to, this will become 0, this will become 1, no? We'll have negative 9g. Yan. So therefore, yung ating particular solution will be x sub 1 equals 3gt plus 9g e raised to negative t over 3 minus 9g. Okay? Okay. Now, balikan natin yung ating figure. Okay? Dito, makikita natin na dito makikita natin na when t is equal to 60 seconds, we'll be able to get x sub 2 and v sub 2 given yung na-form na natin na equation from na-model na natin na equation from this first scenario. Okay? So, let's go ahead and find that x sub 2 and v sub 2 when t is equal to 60. Yan. So, take note when t is equal to 1 minute or equal to 60 seconds, what is yung ating x2 or yung v2 muna, and what is yung ating x2? So, natin makukuha, of course, wala dito sa ating equation na nakuha from here. That will be our x2. Okay, so from v2 will be itong equation na to, no, nakuha natin. This one, no? 3g. Let's copy this. For v2, we have our equation, diba, to be v1 equals 3g minus 3g e raised to negative t over 3. And when t is equal to 60, when t is equal to 60 seconds, this will become v2 3g minus 3g e raised to negative 60 all over 3. v2 will become, labas natin yung calc natin, no? Move lang muna natin ito ng kaunti para may space for the calcu, which is this one. We have 3 times, yung G natin is 9.81 minus 3 times 9.81 multiplied by E raised to negative 60 over 3. This becomes 29.4299 or approximately equal to 29.43 meters per second. Okay? So, nakuha na natin yung ating new value for our velocity. So, that's 49. Now, for x2, we have this equation nga. No? For x2, we have x1 equals 3gt plus 9g e raised to negative t over 3 minus 9g. So, in this case, applying yung ating 60 seconds, therefore x sub 2 will be 3g times 60 plus 9g e raised to negative 60 over 3 minus 9g. Okay, so we have x sub 2 to be, labas natin yung calcu natin, no? Yan, sakto. So, meron tayong 3 times 9.81 times 60, no, plus 9 and then 9.81 multiplied by e raised to negative 60 over 3 minus 9 times 9.81. Double check natin. 3 times 9.81 times 60 plus 9 times 9.81 e raised to negative 60 over 3 minus 9 times 9.81. Yung distance natin would be 1,677.51 meters, of course. Okay, so now this is our new reference. What do I mean by new reference? Kasi, kapag binalikan natin yung ating original equation or scenario, kakaroon tayo ng this one. So, nakuha na natin si x sub 2 tsaka si x sub 1. Ito na yung mga bagong values niya dito. Ang mangyayari dyan, kukunin natin itong scenario ito at ito yung gagawin nating new reference. So, let's go ahead and copy this one. No? Opya. Ano nangyari? Okay. So, kopyahin ko lang to Mali. Yan. So, apply ko lang doon sa last page. Okay. Yan. Okay. Adjust ka lang na konti. Yan. Okay. Alright. Thanks for bearing with me. So, nakuha na natin yung ating value for V2, that's 29.43 and 1677.51. Lagay natin, 29.43, yung ating velocity, 29 meters per second. And then we have 1677.51 meters as our distance. Now, bakit natin kinuha yan? Kasi ito yung ating magiging bagong reference, no? Reference. What do I mean by that? Since nakuha na natin itong value to, we can make this our new zero. Okay? New zero. Paano yun? Well, magiging ganito siya. Okay. Yan. Ang mangyayari dyan, our new t will become yung ating reference. It will become 0. Tapos, yung ating initial distance is 1677.51 meters. Tama? So, kung dito na tayo magsisimula, definitely, kung mula dito hanggang 4,000, kung from here until here, yung 4,000 meters, edi definitely, mababawasan itong 4,000 meters natin kung dito na tayo mag-start sa new reference point natin. This will now become, our new x will be 4,000 minus 1677.51. Yung ating new distance will now become minus 4,000, no? Labas natin si calcu. So, this will become 4,000. Oops. Minus yung answer kanina. This will become 2,300. 2,322.49. So, ito yung new distance na gagamitin natin para ma-solve natin si T mamaya. Okay? Para ma-solve si T mamaya. So, this is our new distance. Ito rin yung ating initial velocity. .43 meters per second. So, same, no? Solving for this T, no? We'll proceed with, again, getting the free body diagram of itong naka-open na yung parachute. So, si Stickman, again, patawarin niya na yung drawing natin. Okay. Sorry. Nakaharang pala. So, yan. So, at this point, naka-open na yung kanyang parachute. No? So, in this case, yan. Okay. So, at this point, na-open na yung kanyang parachute. You can still analyze the forces active on the parachuter, or Sonia Jean, which is the weight, of course, still the same, and the air resistance. This time, K2V. Yan. So, as we know it already, the linear differential equation formed from the 2 Newton's laws will become m dv over dt equals mg minus k2v. Okay, so ano mangyayari? We will have a linear differential equation having dv over dt plus k2 over m times v equals g. Yan. And so substituting, yung k2 natin is actually 105. And yung mass natin still the same ni Sonia Jean, 45 kilograms. Magaan lang. Magaan lang si SYJ. Typical women weight, 45 kilos. 105 over 45 is actually from our calculator, no? 105 divided by 45 is 7 over 3. So dv over dt plus 7 over 3 times v equals g. Okay. So this is our standard form. No? You can identify that P of t here is 7 over 3 and that Q of t is g. And so integrating factor is mu of t equals e raised to the integral of P of t dt, or simply e raised to 7t over 3. Yeah, 7t over 3. So the general solution is actually v e raised to 7t over 3 equals the integral of e raised to 7t over 3 multiplied by g. Of course, dt and then plus c. Move lang natin kaunti. Plus c. Yan. So, evaluating the integral, magkakaroon tayo ng 3 over 7 g, 3g over 7 e raised to 7t over 3 plus c. Tama? And so, dividing e raised to 7t over 3 to the whole equation will give us an expression for the velocity v, which is 3g over 7 plus c e raised to negative 7t all over 3. Yan. So, meron na tayong equation, no, for our velocity, but we still have our arbitrary constant c. And so, employing ating initial value condition, which is when t is equal to 0. Yan. What is our velocity? The initial velocity is yung nakuha natin kanina, which is eto, yung 29.43. 29.43. Yan. So from here, applying it to the equation, magkakaroon tayo ng 29.43. 29.43 equals 3g over 7 plus c e raised to 0. Yan. We know that e raised to 0 is 1. And so c is equal to 3g over 7, or 29 minus 43 minus 3g over 7. So, compute natin sa calc yun para medyo mas madali. So, 29.43 minus 3g over 7. That's 3 times 9.81 over 7. This gives us 25.25 2257. 25.2257. Okay. Now, nakuha na natin si C. So, meron na tayong particular solution for the velocity. V is therefore equal to 3g over 7 plus 25.2257 e raised to negative 7t over 3. Yan. Bakit important na makuha natin to? Kasi we need to find for the distance. Since V equals dx over dt, then dx over dt equals 3g over 7 plus 25.2257 e raised to negative 7t all over 3. And so, separating the variables, the derivatives, 3g over 7 dt plus 25.2257 e raised to negative 7t over 3 times dt, and integrating both sides gives yan. This gives us an expression for x, which is 3g t over 7 plus 25.2257 multiplied by negative 3 over 7 e raised to negative 7t over 3 plus, of course, huwag kakalimutan, c. Yan. That is now our equation. And then again, employing yung ating initial value condition, which is when t is equal to 0. Ayun. What is our x? So, mula doon sa ating situation kanina, yan. Since ito na yung bagong reference natin, when t is equal to 0, x is equal to 1677.51. 1677.51. One six seven seven point 0.51. Yan. So applying this to our equation, we can solve for C, no? And so we're going to have 1677 0.51 equals 3gt over 7 multiplied by 0, 3g multiplied by 0, and we have 25.2257 multiplied by negative 3 over 7 e raised to 0 plus c. E raised to 0 is 1, and this becomes 0. And so meron tayong c equals 1677.51 minus 25.2257 multiplied by negative 3 over 7. So, labas natin yung calculus natin. Let's try and compute for this one. So we have 1677.51 minus 25.2257 multiplied by negative 3 over 7 is 1,688 1,688.3210. Yan. Now that we have this C, meron na tayong particular solution. So, no, x is equal to 3gt all over 7 plus, or pwedeng i-minus na natin, minus, multiply na siguro natin, 25.255 divided by 3 over 7. This will become plus 10.81. 10.8110 e raised to negative 3 over 7, or rather 7 over t, 7t over 3, no, plus 1688.3210. Ayan. Now that the equation is complete, we can now solve the problem. And that is when t, or rather when x is equal to, ano yung ating new distance? Kasi nga, nag-refer tayo dito. Our new distance is 2322.49. 2322.49. Okay. When x is equal to 2322.49. Sorry, 0.49. Okay. What is t? So we have from our equation x to be 2322.49. 2322.49 equals 3gt all over 7 plus 10.8110 e raised to negative 7t all over 3 plus 1688.3210. Solving for t by shift solve. Okay. Labas natin yung calcu natin. So we have 2322.49 equals 3gt, 3 and then 9.81 multiplied by x over 7. Of course, let t be equal to x plus 10.8110 multiplied by e raised to negative 7x over 3. 7x divided by 3 plus 1688.3210. Ayan. Shift solve. Solve for t. We have 150. At t is equal to 150.8387 seconds. Or in how many minutes kaya? 2.51 minutes. approximately equal to 2.51 minutes ang landing niya sa ground. Yan. Alright. Okay. So, to summarize, anong ginawa natin? The answer is 2.51 minutes or 150.8387 seconds. To summarize, what we did is we considered two situations. First situation is initially, noong wala pa siyang what do you call this? Nung hindi pa siya nag-open ng chute, so binigyan kasi tayo ng dalawang conditions, ng dalawang proportionality constant. Nung closed pa yung parachute and nung open yung parachute. Nung closed pa, dinetermine natin what would be the distance and the velocity of SYJ kapag binuksan niya na yung kanyang parachute. And that is after 1 minute. And then after that, nung na-compute na natin yung distance and velocity at 1 minute, yun yung ginawa nating reference for the next succeeding, which is yung other half ng 4,000. Kaya binawas natin yung 4,000, binawas natin yung 1677 dun sa 4,000 para ito na yung magiging new distance natin. Since ito na yung new reference point natin, dito na tayo nag-start. Okay? Yun. And so, we did the same. We modeled an equation and then solved for an equation that would, equation of motion that would describe, of course, what distance and the velocity of the problem is. So, yun. Yun yung ginawa nating atake dun sa problem. So, the answer is 150.8387 seconds or 2.51 minutes. Oops, sorry. Alright. So, for the problem set, ito yung ating problem set. 2 items. And that ends my presentation. As Salsalians, let us pray. I will continue, oh my God, to do all my actions for the love of Thee. Saint John Baptist de la Salle, pray for us. Leave Jesus in our hearts forever. In the name of the Father, the Son, the Holy Spirit. Amen. Thank you guys for watching and see you again in our next discussion. Bye.